Hello all, this is Lisha, currently studying in 7th semester CSE at Sri Venkateshwara College of Engineering. Now I am going to explain the topic on cryptography, that is Diffie-Hellman key exchange, the algorithm. First, introduction to cryptography. Cryptography is the practice of secure communication in the presence of third parties. It involves technologies for the secure communication in the presence of adversaries. The cryptography has been used since ancient times, but modern cryptography uses mathematical algorithms and computer programs to ensure secure communication. One of the key challenges in cryptography is the need to exchange secret keys between parties. The Diffie-Hellman key exchange algorithm is a method for securely exchanging keys over an insecure channel. In this section, we will introduce the basic concept of public key cryptography and the need for key exchange, and then dive into the details of the Diffie-Hellman key exchange algorithm. First, the public key cryptography. Public key cryptography is also known as asymmetric cryptography, is a cryptographic system that uses two keys, one is public and one is private, to encrypt and decrypt the data. The public key can be freely distributed while the private key must be kept secret. The public key is used to encrypt the data, which can then only be decrypted with the corresponding private key. The advantages of public key cryptography is the public key cryptography offers several advantages over symmetric key cryptography, including increasing security and ease of key distribution. The application of the public key cryptography is used in a wide range of applications, including secure communication, digital signatures, and many other like online transactions and all. Next, the need for the key exchange. In cryptography, the secure communication requires both parties to have a shared secret key that is used to encrypt and decrypt the messages. However, the challenge is to establish this shared secret key over an insecure channel without any prior knowledge of each other keys. This is where key exchange algorithm come to play. The symmetric key exchange methods require both parties to have the same key beforehand, which can be difficult to achieve in practice. The asymmetric key exchange methods use public and private keys, but they are computationally expensive and may not be practical for large amount of data. The Diffie-Hellman key exchange algorithm provides a solution to this problem by allowing two parties to establish a shared secret key over an insecure channel without any prior knowledge of each other's keys. Next, coming to the Diffie-Hellman key exchange algorithm. This is a method of securely exchanging the cryptographic keys over a public channel. It was invented by Whitefield Diffie and Martin Hellman in 1976 and is widely used in modern cryptography. The algorithm allows two parties to establish a shared secret key that can be used for secure communication without over-transmitting the key itself. The security of the Diffie-Hellman key exchange algorithm is based on the difficulty of computing discrete algorithms in a finite field. The algorithm is considered to be secure against eavesdropping attacks, but it is vulnerable to man-in-the-middle attacks if not used in conjunction with their security measures. Now, how the Diffie-Hellman works, let us see. It is a method, as I told before, which is securely exchanging cryptographic keys. Now, let us see the step-by-step process. Let us take two people. that is Alice and Bob. Alice and Bob agree on a prime number P and a base G, which are public parameters. The second step, Alice choose a secret random number A and computes A is equals to G power A mod P. She sends A to Bob over the public channel. The Bob chooses a secret random number B and computes B is equals to G power B mod P. He sends B to Alice over the public channel. The fourth step is Alice computes the shared secret key, that is K is equals to B power A mod P. And the fifth point, Bob computes the shared secret key, that is K is equals to A power B mod P. This shared secret key K can be used for secure communication between Alice and Bob. The security of the Diffie-Hellman key exchange algorithm relies on the difficulty of computing discrete algorithms in a finite field believed to be hard problem. Now, the security considerations. What are the security considerations of the Diffie-Hellman key exchange algorithm? This provides a secure method of two parties to exchange the cryptographic keys over an insecure channel. However, there are several security considerations to keep in mind. Some of these are man-in-the-middle attacks. That is, the Diffie-Hellman key exchange algorithm is vulnerable to man-in-the-middle attacks where an attacker interrupts and alters the key exchange process. To prevent this, it is important to use authentication and integrity checks to ensure that the exchanged keys are not tampered with. The second point is key size. The security of the Diffie-Hellman key exchange algorithm depends on the size of the keys used. Using keys that are too small can make the algorithm vulnerable to brute force attacks. It is important to use keys that are large enough to prevent such attacks. Implement flaws. Poor implementation to this algorithm can introduce vulnerabilities. It is important to use a well-vetted implementation and to follow the best practices for secure implementation. Now let us see the real-world applications of the Diffie-Hellman key exchange algorithm. First is secure communication between web browsers and servers using HTTP protocols. The second point is virtual private networks, that is VPNs, for secure remote access to corporate networks. The third point is secure email communications using PGP, that is pretty good privacy encryption. The fourth point is secure messaging and voice calls in various instant messaging apps such as Signal and WhatsApp. Now let us see the limitations and the future developments of Diffie-Hellman key exchange algorithm. One of the main limitations is that it is vulnerable to man-in-the-middle attacks where an attacker intercepts and alters the communication between two parties. Additionally, this algorithm does not provide authentication, meaning that there is no way to verify the identity of the person or identity on the other end of the communication. And the future developments are researchers and cryptographers are continuously working to improve the algorithm security and efficiency. One area of focus is post-quantum cryptography, which seeks to develop algorithms that are resistant to attacks from quantum computers. Another area of development is the use of elliptic curve cryptography, which offers a more efficient alternative to traditional Diffie-Hellman key exchange. Now, the conclusion. The Diffie-Hellman key exchange algorithm is a crucial component of modern cryptography, providing a secure method for establishing shared secret keys over an insecure channel. This is all about the Diffie-Hellman key exchange algorithm. Thank you.